All right, so Francisco mentioned that these problems were coming up, and so I want to kind of take a look at those and go through this and take a look and address ones like this, and also uh, this one here was it I think maybe it was number 15. Okay, that was 15. What? Oh, okay, it's being silly. All right, so anyway, here's the basic idea. Okay, if you have a definite integral going from a to b of a function, and the best way to do it would be a function of another function of x dx, then what we're going to do is we're going to say that depending on however many subintervals, and so we'll say n subintervals, is the Riemann sum. If you remember, Riemann just means rectangle. Okay, then the idea is that it's going to be the summation, the segment notation, k from k equals 1 to n, so whatever the n subintervals is, so 5, or then n is 5, then that's 5 subintervals. Or if we have an infinite number of them, then what's going to happen is we'd actually get what this is, and we'd talk about a limit, and so we'll hit on that as it comes up. But here's the basic idea. It's going to be the function from a, so whatever your starting point is, so that starting point. Okay, so you get that starting point, so it's going to be a plus, so whatever. So sometimes it's 2 or 3 or whatever. And so it's going to be a plus, and then we're going to have, instead of u of x, it's going to be u of b minus a over n k. And so we're going to, everywhere there's the x, we're going to replace it with that. And then on the outside, we're going to actually do this again. So that's b minus a over n. And this is sort of like this is where the idea, this is the dx part. So that one that we were talking about that I showed you, that first one, they had a whole bunch of different ones. And so it's easiest just to go from the original, from the definite integral to the summation notation. I mean, sometimes they'll ask you to work backwards. On the test this year, apparently, from what I understand, it's going to be all free response. So you don't need to worry about the multiple guess. But if I were to guess what that would look like, they would give us a problem and they would say something like, hey, going from -1 to 4 of sine of x dx. And so you have your a, your b, and your f of x here. So with that in mind, so then we'd have, this would come out, and we'd have the sigma notation going from k equals 1 to n. And if we did like the limit as n approaches infinity, then that would actually give what this is. So limit as n approaches infinity. Okay, so we'd have f, which in this case is sine, a, it's because you have the a, that starting point, so -1, plus, it's always that plus right there. And then we look at this part, the u of x. And since it's just x, we're just actually going to put this right in here, this b minus a over n times k. So b minus a, and so we'd actually have 4 minus -1. So b is 4, a is -1 over n times k. And then again, we'd have that on the outside, that b minus a over n. So 4 minus -1, we can just actually fast forward that now to 5 over n. And so then we can just clean this up, and so we get that limit as n approaches infinity of, from k equals 1 to n, of sine of -1. And then this is going to be plus 5 over n k and 5 over n, which, or 5k over n, if you will, like that. Now, it's not the only way that this can actually be produced, because the other ones, if we look at the other ones and say, you know, the question itself was, hey, which one works, 1, 2, or 3, or all of them? And so right here, 1 definitely does produce that. So we're going to take a look at those other ones and see if they do. Of course, if it's, since we don't, you know, if it were a multiple guess one, then you could, if we knew that we got a second one, then obviously, then all 3 of them would be, because those are the only options, either 1 only, 2 only, 3 only, or all 3. But we'll go through real quick on those ones. So the next one says the integral from 0 to 5 of sine of -1 plus 5x, oh, I'm sorry, no, -1 plus x dx. And so again here, a and b, and so this is going to be the limit as n approaches infinity, going from n equals 1 to, I'm sorry, k equals 1 to n. I get that mixed up a lot, so be careful with that. K on the bottom and right up here on top. But this is for equality. It actually does equal that. It actually equals this, not just that it, you know, it's not just an approximation like the other ones would do. This one actually is equal to it. And so then we have this, okay, so again, f, the function, sine. Now this one starts at 0. So it actually, I'm just going to put 0 plus. And then we have all that stuff in there. And so then this is going to be -1 plus that x. And now that x, again, we're going to change and replace that with the b minus a, in this case 5 minus 0 over n times k. And then on the outside, we also have that 5 minus 0 over n. And that one on the outside just has the 5 minus 0 over n. So now we can clean that up. The limit as n approaches infinity of sigma from k equals 1 to n of sine 0 plus -1 is just -1. 5 minus 0 is 5 over n, and then we could throw that k up there on top, and then we have 5 over n. And so we get that, and then 2 also works. And just, I know, you know, obviously now the 3 works, but you know, more importantly is how could we get there from that? Because this one's a little bit different, because it says 5 times the integral from 0 to 1 of sine of -1 plus 5x dx. And so with this, we still have that 5 times, now it's 5 times the limit as n approaches infinity, going from k equals 1 to n, caught myself before I wrote it, or said it, sine, okay, and now we're going to start at, again, starting at 0, because that's our starting point, 0 plus, and then we have -1 plus 5, and then here, we're going to have that, that x, we're going to replace the x with the b minus a, and so in this case, 1 minus 0 over n times k, and then on the outside, we need another parentheses, and then on the outside we have the 1 minus 0 over n. So just like with anything else with limits, if you have that on the outside, we can multiply it in, and we can either put it in front, or we could put it with that guy. And so 1 minus 0 is 1 times 5 gives us 5 over n, and then we have the limit as n approaches infinity of the sigma notation k equals 1 to n sine of -1 plus, and then that's 5 times 1 times k is 5k over n, like so. And we get what the other one was. Okay, now for all of these, this is for the equality one, and most of the time that's what it's going to be, and they might want to see this. I can imagine them asking a question like, hey, here's this definite integral, write out what the function would look like. Now, the next one is a little bit different, and this one actually says, it says, hey, which of the following is the left Riemann sum approximation? That approximation right there, because that approximation, that means that we don't actually have to worry about, we're not going to do that limit. That's why none of the answers have the limit on it. But, so we're going to do this, okay? And now the left one is a little bit different than the right. So left, okay, about right there. Okay, so left hand. So with this one, what's going to end up happening is because instead of, remember these are all a bunch of, rectangles, okay? We got a bunch of rectangles going on here. And if we want to start, the idea then is like this would be 0, k equals 0, k equals 1, k equals 2, and so on. With these ones, with all the ones that we actually did on the last one, they were all right-hand ones because we start at k equals 1. But instead what we're going to do is we're going to still start with k equals 1 on the sigma notation. Still going to go from k equals 1 to n. But instead, when we go to do our function, we're going to have that function, that a plus, and then it's u of b minus a over n times k minus 1. That way, this is the idea to go onto the left side, and this is special for the left-hand sum. And then obviously we still need, on the outside, we still need the b minus a over n. And so the problem is given, and it says 2 to 8 of cosine of x squared, like so, dx. Okay, so with this, we'd hit, and this is, we're going to have it, and remember this is a, so there's approximation, so the approximation, there's only one, yeah, 2 p's in approximation, so there's approximately, and then we have the sigma notation, k equals 1 to n, and then it's going to be cosine, okay, and then we have, in here, we got that thing squared, so we could put the square right there is okay. And then we're going to start at 2, okay, because that's our a, so it's a plus, and so a is 2, so 2 plus, and then we have the x. So now we're going to do, okay, so it's b minus a, so b minus a, so that's 8 minus 2 over n, okay, and then we're going to have the k minus 1, like so. And then on the outside, 8 minus 2 over n. So this comes out, that is approximately, because we're talking about the relationship between these two. This is equal because this is a relationship between these two. K equals 1 to n cosine 2 plus, and then that's going to be 6 times k minus 1 over n squared. All of that times that 6 over n, like so. And so with this then, right here, take a look and see. Actually, let's just, so we got that, and then, so here's what I'm going to do. I'm going to go and I'm going to show you that that's what the right answer is, like so. And that's the idea. So there you go. There's a little something for you. Okay. Yeah, so now that I kind of got a better idea of figuring this out, look for these more often. They're going to come more often. That's a promise. So this is the idea. If it still needs more clarification, let me know. All right. Be well. Take care. And this is Safira.